All of the problems from these videos can be downloaded from accountingworkbook.com. Go to the website, click the PDF link, and you can download a copy of the workbook for yourself. Also on the website, you'll find all of my accounting videos, not just the ones I upload to YouTube. In fact, on the website, there are over 100 extra videos that I haven't uploaded to YouTube. So I do hope you'll check out accountingworkbook.com. Okay, let's get started with the problem. Let's examine problem 9.2a, direct labor variance problem. So just as I did with materials, with labor, I like to think about drawing this little template first. It's a little bit different from the materials template. So I go AQ, AP, AQ, SP, just as I did with materials. Here's where this gets different. Because with materials, I can have amount that I purchase and an amount that I use. I need two different kind of prongs. With labor, the amount that I pay for, I have to use. It's not like materials. Like if I'm the guy that buys pork, I can leave some pork in the fridge or the freezer and save it for next month. If I pay for labor, I can't put my employee in the fridge and save them for next month. I pay for them, it's done, right? I pay their wage and it's done. So because there's no difference between what I purchase and what I use, I can prepare the prongs in this manner. I don't need separate prongs, so it becomes an easier problem. So let's do it. Frank's Bikes makes fixed gear bicycles. The company set the following standards related to labor. Each bike should take 4 direct labor hours to manufacture at a cost of $15 per hour. Well, there's my standard price. Remember, when we did materials, our standard quantities were always like kilograms or liters or pounds. Well, with labor, our standard quantities are always hours. So our standard quantity is 4 direct labor hours. Our standard price is our rate per hour, $15 per hour. For August, the company produced 160 bicycles and employees worked 700 direct labor hours. Okay, that's our actual quantity worked. The company's total direct labor cost for the month was $10,000. Okay, well, our AQ is $700 hours, Our AP, our price per hour, we don't know, but we know in total we paid our employees $10,000, so we can work backwards and we can figure out, okay, well, what was the average hourly rate of our employees? 10,000 divided by 700 is $14.29 per hour. Moving over to the next prong, our actual quantity, well, 700 hours. Our standard price, you'll see this called standard rate as well. You'll see slightly different terms. You might see AH times SR in your textbook. I just use the same ones every time because it's like, I just find it easier. But your text might say AH times SR for this, because actual hours times standard rate, but actual quantity is 700 hours. Our standard price for labor is $15 an hour. So 700 times 15 is, let's calculate. It's 10,500, I think. Okay, so we can do a variance here. The difference between the two is $500. Now, we've got to say, is this difference a good variance or a bad variance? Is this something we would want or not want? And we look at what's different between the two formulas. So again, 700 hours, that's the same. I paid my employees $14.29. I had expected to pay $15. We're the owner now. This is great news for us. We're terrible capitalists here. We're happy to have underpaid our employees. More money in our pocket. That's $500 less in their pocket, more in our pocket, and we're greedy in this scenario. So this is a favorable variance if you're running the company. You paid less in wages than what you would have planned to have paid. Moving over to the last prong, standard price here is $15 an hour. It remains $15 an hour. Our standard quantity, remember, we're answering this question. Given the actual number of units produced, how much labor should have been used? So given the fact that we actually made 160 bicycles, How many hours would we think it would have taken? Well, 160 hours, or 160 bicycles, and it's supposed to take 4 hours per bike. 160 times 4 is 640 hours. Our standard price is $15 an hour, so 640 times $15 an hour is $9,600. So comparing these two, 10,500 and 9,600, we're off by 900. There's a $900 variance. Now, is this variance good or bad? Is it favorable or unfavorable? Well, let's look at what's different between the two. And in this case, it's not that SP 1515. No, it's the hours. 700 hours versus 640 hours. So let's think about what it means. My employees worked 700 hours. They ought to have worked 640. If we had 160 bicycles to make, it should have taken them 640 hours. It took too long. They were inefficient. This is an unfavorable variance. These variances are called the direct labor rate and efficiency variance, or DL rate variance and our DL efficiency variance. And you can see the rate variance is favorable. The efficiency variance, though, is unfavorable. So let's think about reasons why. Why might we have a favorable rate variance? Well, perhaps we had more inexperienced employees working. Maybe our employees make a range of wages from like $10 to $20. The most experienced make 20, the least experienced make 10. Well, if my mix is usually half and half, and this time I had a few more inexperienced employees, I might have ended up paying a lower rate just because I have more newbies working. And actually, that makes sense to have a lesser efficiency variance as well as a possibility here. Other reasons I might have paid lower. Perhaps my employees received a pay cut. Perhaps there was a reduction in pay for some reason, like maybe it's the economy is bad, and I say, look, I'm going to have to let people go, or we're all going to have to take a pay cut. And the employee said, well, let's take that pay cut. That is a possibility. More often than not, it's labor mix, so it's like less experienced workers, more experienced workers, or maybe we've hired in some new workers at a lower wage rate. On the right-hand side, our direct labor efficiency variance. Why might it be unfavorable? Well, perhaps the workers are less experienced. Perhaps that price variance kind of indicated that we had less experienced workers. So if we have less experienced workers, they are likely going to make more mistakes or just maybe move slower. That's a possibility. I'm not saying that's for sure, but that's definitely a possibility. Why else? Maybe the workers are just lazy. Maybe there's bad supervision going on, or maybe there was something going on that caused a delay in manufacturing. Maybe the machine slowed us down, or something like that. There's a million possibilities for why our workers may have been slower than we expected, and if I asked on a test, I'd just expect the student to come up with a reason why possibly might the workers have been slower or faster, if this was favorable, than what we would have expected. All right, folks, that's it for this video. Stay tuned for the next one.